Hello everybody and welcome to OpenCV weekly webinar. This is episode 52, if you can believe it. I'm here with Vahan and Oscar from SuperAnnotate. This is going to be a really exciting show. You'll notice that our usual host, Satya Malik, is on assignment and is not here today, so I'll be flying solo. It is I, the guest host with the guest most, Phil Nelson. Thank you for joining us once again. I'm joined here by Vahan from SuperAnnotate. Go ahead and say hi and introduce yourself, Vahan.
Hey Phil, thanks a lot for organizing this. First of all, I'm Vahan. I'm one of the co-founders of SuperAnnotate. I'm the CTO of the company. And previously, before starting the company, I was doing a PhD research in machine learning, computer vision. So very much the right place to talk about some trends in computer vision. Thanks.
Yeah, I think so. And if you're just joining us here, I see more of you filtering in. Our topic today is top trends in computer vision for 2022. And we've got two of the best to talk about that. Also with us is Oscar from SuperAnnotate. Go ahead and introduce yourself, Oscar.
Thank you, Phil. So hi, everyone. My name is Oscar. I'm leading SuperAnnotate's solution engineer team. So more than happy to talk about these trends that we find out by talking to our clients all over the world and present them to you and hopefully have a fruitful discussion about it as well. So thanks for having us here.
Yeah, and thanks for joining us. We do a couple things every week here as a reminder, one of which is Q&A from you in the Zoom audience. So at any time during the webinar, please use that little button at the bottom of your screen and ask any questions you have. We'll try to filter them into the conversation where they fit. And if they don't fit, we'll try to ask as many as we can at the end of the webinar, time permitting. We will also be doing a special giveaway. Would you like to tell them what we'll be giving away to one lucky Zoom winner today, Vahan?
Absolutely. So would like to give away about 7 seats in our SuperAnnotate platform for 1 year period. That will be worth of thousands of dollars of software. So you should please be active, ask questions. We'll be happy to answer.
Incredible value here on our special giveaway. We'll be doing that at the end of the presentation in about 45 minutes, so please stick around for that. Thousands of dollars in value of SuperAnnotate, one of the top computer vision and AI platforms in the world, so stick around. Vahan, Oscar, it's your show.
Thanks. I'll start sharing the screen and then Oscar, feel free to hit in and then I'll continue. So there we go.
Great. So yeah, I'll take it off here. So today we will be talking about some of the top computer vision trends that we generally see and talk to our clients about. But first, just to give you all a brief overview of SuperAnnotate and what we do. So at SuperAnnotate, we really help companies build the highest quality data sets for all sort of machine learning initiatives. And we support companies with our expertise in data annotation or labeling, data management, and ML ops. So Vahan here, together with brother Tigran, founded SuperAnnotate back in 2018. And so far, we raised more than $2 million from well-known institutional investors. And our last round was actually one of the highest Series A raising in the fields. And we've grown a lot. So we have a team of over 150 people, all CV enthusiasts all over the world. So we have people in US, Europe, Asia, a little bit everywhere. And last year, we were recognized as one of the top 100 AI companies and one of the few in the data labeling space by CB Insights. And moreover, we are also the top ranked platform on the data labeling category on the G2, part of this magical top right quadrant. So that's a little bit about us. And more than that, we are very helpful or thankful for all of our advisors that helps and support us a lot. Some of them you might know. There are well-known professors like Trevor Durrell and Peter Abil from Berkeley, but also Gary Bradsky, one of the founders of OpenCV, as you guys probably know. And we're so happy to get the advice and help from some of the best minds in CV and AI and have the support of like such a community builder like Gary Bradsky. It's just wonderful.
Hey, Gary Bradsky, I know that guy.
So great, yeah, and we're trusted by many leading organizations in different industries, everything from automotive to remote sensing, medical to retail, and we really support AI and ML initiatives in all different spaces.
So
But
some very cool companies there. I see Renault, a bunch of,
yeah,
yeah.
for sure, it's an ever-growing list. Like we try to keep it updated, but with the growth speed we have, it's difficult to keep it up to date all the time. But
It's
we're
a
happy to
great
see.
problem to have there.
For sure, yes.
Too many people using your stuff. You can't list them all. Yeah.
Exactly, yeah. It's a comfortable problem to have. But today, what we will be talking about is like some trends to watch out for and to keep in mind, and hopefully dive a little bit deeper into. And we're going to start with CV ops. So this is computer vision operationalized, so to say. So some of you guys have might heard of like DevOps or MLOps. CV ops is very similar to MLOps in that case, and it's all about using CV models instead of ML models, but many CV models are, of course, ML based in this case as well, but about image based systems in some case. So it's all about practices for the development and deployment of CV or ML models in production. So there can be many steps here, many stages, and many different systems and platforms, but CV ops will all be about this kind of interconnectedness, connect all of the pieces together, create a good, and the aim is to have a operationalization of CV and ML models. So everything from best practices in model design, data storage, labeling, of course, model testing, deployment, and other CI/CD practices, for example. So everything tied together, not specifically for one platform, but more this kind of overarching thinking of really getting it from kind of trial and error or testing to a productionalized setting. And Vahan, perhaps you can tell us why this is becoming more and more important.
Yeah. Thanks, Oscar. So generally, the ML and CV is becoming a lot more commonplace for engineers to build. There are special ML engineers, CV engineers that are building AI applications. And what we have noticed is that from 2017 to 2018, the number of AI models doubled. And the same thing happened between 2018 to 2020. So we have this growth of AI models that what people were doing before is having some playgrounds, competing with models, and then creating algorithms that hopefully in the future will be into the production. But as you're growing with those models exponentially, it is becoming very, very hard of creating several models that will work on the same level of accuracy that you want. And the research is showing that about 88% of the plans around the AI that people are planning are really failing. And generally, there is nothing wrong with the algorithms that people are trying to solve, but the wrong thing there is that they're not really be able to put the right infrastructure on the CV ops side or the ML ops side in order to create models that will keep improving or create several models. So moving away from a POC to something that is very measurable to value in a production is becoming really, really hard without this CV ops enablement. And if I will give like two different examples in computer vision, so basically we're going to discuss static cameras and dynamic cameras. And then in each of them, let's say we're dealing with static camera and we're trying to build a computer vision system that will work really well on different angles, different backgrounds, different lighting conditions, weather conditions. There is so many more edge cases.
By static here, you mean specifically cameras that are rigidly fixed in place?
Exactly. So security cameras is a perfect example, Phil, but then it can be so many other use cases with manufacturing. I don't know. There's so many more use cases.
Would cameras that can like pan and tilt count as static cameras?
Yeah, I would assume so, because they're still in the same place. So that's where the angle is coming right into the equation. So previously, what was common thing to do is to gather a huge data set and try to build one model that will work equally well for all these different scenarios. And it was becoming very, very hard problem when you're in a retail store and then you're operating in 10,000 retail stores with 1 million cameras now. And the challenges there are very, very hard. And what people realize that they can do is to build one small model for particular camera. So now, instead of like building one gigantic model that will work in all use cases, people are building a lot of different models that will work on that particular angle and that particular lighting conditions and so on, which is a lot easier thing to do.
And but you'll have your results will be much more specific and precise if you're building to the exact FOV, the exact background, the exact, if the time of day, the light's the same every time, that sort of thing. It's normally we hear about overfitting as a bad thing, but in this case, you're saying for overfitting, for lack of a better term, can be good.
Yeah, exactly. So basically, if your camera is in the same place, you know that this is all the data that you're going to get. So it's not really an overfitting, but in this case, the general term is overfitting, and it is a good thing. The problems are becoming when you're building a pipeline to manage thousands of models, then all of a sudden it is becoming super hard to operationalize all this infrastructure to have a production of thousands of cameras.
And we're also, one thing to consider for the audience here too is that in these sorts of, say for security cameras or safety cameras in industrial environments, a 1% improvement in accuracy is gigantic. I mean, that's a huge improvement. And so every little bit of that is worth doing these extra steps and going down these different paths.
Yeah, totally agree. So, and then I think we already discussed this with Phil, why it should work, because really the test environment and the training environment is really the same. So we're overfitting to the right place and location. The other aspect is what we can do with dynamic cameras. The challenge of building a generalized model that will work equally well in Nevada, Arizona, and in, I don't know, Toronto is going to be super hard, because again, background conditions are very different. The traffic signs can be very different. I'm talking about autonomous driving because we see this a lot. And instead of using now one gigantic model.
That was a very dynamic looking camera, by the way. It kind of looked like the Cylons from the old Battlestar Galactica show from the 80s.
Yeah.
Like Ursat's Darth Vader camera over here.
Yep, you should be able to detect very small movements with those cameras.
I'd hope so. That's probably like, how much do you think that costs? I see some LiDARs in there. That's probably like $100,000 piece of kit there.
Yeah, I think at least 30,000 will definitely be there. But let's bring the example back with autonomous driving. It's easier to imagine. As your car is driving to one location to another location, generally those models can be 50 megabytes, 200 megabytes. It is really easy to kind of download a new deep learning model and then deploy that model in a new environment, or keep everything and then switch the models within the car, right? So now instead, when we're talking using one model, you don't really want to use one model. You just want to use one model per neighborhood or per some type of fixed area. And when you're switching the area, then you kind of switch the model as well. That way you will have like a very dynamically switching models that will work accurately. And again, building one model for each neighborhood, this will again become like an overfitting model for that particular neighborhood, will give you a really high accuracy. And it will work since we're again dealing with the same problem, that the test data set and the training data set are really coming from the same environment. So this is a trend that we see that many companies are doing, and since we're dealing with hundreds of customers that are building CV ops and AI applications in computer vision, in these cases, CV ops are becoming very much requirement to organize and then build it in a right way. So to have a right file management system, model management system, model versioning system, data versioning system, APIs that can go and do all those things automatically are becoming very, very essential for any complex AI project to succeed.
And one of the problems here is, just to briefly talk about data storage. The data versioning is a difficult issue here because a lot of the times we're talking about, binary input data that are, can be fairly large file size wise. It's not trivial currently to, send a full data set back and forth in a lot of these machine learning applications. Like, say, for example, I'm a fan of, Clip and GAN, like doing generative art. And ImageNet, the larger ImageNet data set's like a gigabyte, just by itself. And so that's not fast to just download to a device or to transfer to a device. And that speed is necessary for these, try to train this overfitting style. But it also means that maybe we can have smaller models, doesn't it?
Absolutely. So switching to the next topic, Oscar, can you give a small introduction and then we can continue this as well?
Yeah, absolutely. So what we're going to talk about next is something that's become more popular called data-centric AI. Proponents here, known people like Andrew Nguyen and others in the field have been pushing for a more data-centric mindset when it comes to AI in general. So it's all about putting focus on the data and not necessarily as much on the models. And if you think about competitions on Kaggle or what you do in the school or other kind of data science competitions, it's very focused on the model building side. You usually get a data set and then you're going to build a model or something that performs the best on that one. But in real life, working with ML problems, the focus should be more kept on the data because there is usually the need for you to build your own data set. You're not going to find exactly the same setting as before. And the major part where you can actually have some increased performance is on the data side of things. So if we just keep that focus as we're going to do as we did earlier in school and competitions and so on, it's not going to be working that well in actual real life. And there's a quote here about if 80% of machine learning work is data preparation, then ensuring data quality is the most important work of a machine learning team. That really rings true here because you need to keep data top of mind and ensure that that's the case because models are very important, but with sort of like software 2.0, where the objectives are based on optimizing a criteria instead of feature engineering the code, we mean that like ML models just base their performance on data. So data is the new source code for these models, and it's more important than ever. So we need to keep data top of mind and manage it with really great care. So going more data-centric helps focus on the data part of the projects a lot and really value that. So instead of tweaking things into infinity, focus on the data parts. And the problem here, as you can see on this kind of slide set, is that imperfect data plagues many CV and ML projects. And imperfect data is all about the inconsistencies within the data set, because we want a ground truth that is supposed to be a ground truth, but it will still be generated by people, right? So we need to make sure that it's not subjected to too many human errors and that we have a case of, what do you call it? Good annotations without that much bias, for example. So the imperfect data also comes into play with bad examples of data points like blurry images and the like. And we want to make sure that when we have our data set, it's really good and good for our use case, so to say. So there needs to be ways to handle these inconsistencies and keep track of the data, just like code with version control and so on. And I think Vahan had some more points on this as well.
Yeah, so when we're talking about imperfect data, I would like to touch 3 bullet points in here, right? How to deal with the bias with imperfect data, how to use search and visualization techniques to kind of help you to further improve your imperfect data. And then why versioning is so important in kind of, again, helping to improve your imperfect data. So, and then I'll give some examples what we're doing on our end in SuperAnnotate to kind of tackle this problem. When it comes to the bias, there can be many different types of biases. So it can be class correlation bias. So it can be an annotator bias, let's say, or it can be the QA bias, or it can be really the annotation time bias. At the beginning, the annotators are starting very fresh, and then at the end of the day, then there is a bias in the evening, let's say, that they're starting performing worse and worse. And then basically, when you're dealing with such a high variable bias systems, keeping everything with your annotations is becoming very, very essential, because you need to understand who did what, when, at what time, how, whether they were tired or not, and so on, in order to kind of detect that bias and potentially improve your data set by eliminating the bias. So on the right side, you can see just one simple bounding box that we have. So all you need in general is those 4 coordinates. I don't know if you can see it or not on the point side, but really we're keeping who did that, when did that, under which role they did it, and so on. So it really becomes an easier to kind of extract that information and run some statistical tests in order to detect those biases. So here is a perfect example from class correlation bias, right? So you have Rick and Jen. They have been both labeling their data sets, and we have 3 different classes. And on the bottom left of each of those confusion matrices or correlation matrices, you can see that car and bike are correlated 35% for Rick, but they're only correlated by 2% for Jan. Well, this means that there is a class correlation bias between 2 different labelers, and for some reason Jen doesn't like to put cars and bikes together, or it might be the opposite. Maybe Rick likes to put something that is a bike when it's not a bike, and then when they see a car, then they also put a bike. In this case, like figuring out those biases and then eliminating and giving the right feedback to the annotation teams are becoming very, very crucial to creating high quality data sets.
What about the bias of the people that are looking for biases?
Oh, it's even a harder problem, right? Because
it's turtles all the way down, as they say.
Yeah, you have the volatility of the volatility, basically.
Known unknowns. Yeah.
Yeah, we said it before, like you can never eliminate bias fully, but just reduce it as much as you can.
That's a great way to look at it. I think a lot of people have the wrong idea, or they try to sell certain solutions as eliminating bias, when in reality that's not possible. We just try to do our best, and it's way more realistic to have that mindset, I feel.
Great. So let's go with the second type of problems that can happen with the imperfect data. Having a great understanding and insights, what's in your data, getting the distribution for the classes, I don't know, for the attributes, visualizing the annotations on top of the images are becoming very, very essential to detect some of the potential mistakes. And you can have an ML algorithm that can not really find mistakes, but then they can increase the probability of finding a mistake, let's say. And then once you find those potential bounding boxes or polygons, you need to have the right query mechanisms and visualization techniques to really see whether the prediction or the annotation or the combination of those are done correctly or not correctly. And then this is really bringing you this problem of searching what a needle in a haystack, where finding those mistakes are becoming really hard, and you need to have the right tooling and infrastructure to do this. And again, when you have this very rich data set, when you're performing the annotations, it's becoming very, very easier to kind of put different queries, combine those different queries together, and then find maybe out of 10,000 images, here are the 100 images that will be potentially containing mistakes. So yeah, so this is the second part that we want to kind of bring it up as what is becoming very important in those data-centric AI applications to improve your data set. And then here is an example from our platform. Basically, we have this nice view where on the top, you will be able to kind of search anything you need. So you can see here I am searching all the boxes where there is more than 10 boxes, and then I want to search the class name is equal to ball. So this will find all the images that have more than 10 boxes and with the ball. And if I want to change the number of columns, the different visualization techniques will really help you to kind of search those images and find the potential mistakes. And then the third thing, which is becoming more and more bigger problem for mature AI companies, is that when you're dealing with one version of data sets, you build a model, you realize that this model is not performing well, and then you went and corrected somehow your data set, the annotations, you think it's going to perform better. The next day you come and then your model is worse than what you had before. And then, so you have no way of tracking and kind of going back because all the information that you did is already lost. So having a good versioning system that will help you to create very quick models and then iterate with those models are becoming, again, very essential to keep improving, because this is an experimental game. You try something, it works out, you try something else, it doesn't work out, and then you want to iterate as fast as possible.
I'd just like to point out here, I'm a big fan of One Punch Man. I actually just started reading the manga. So shout out to Saitama over here.
Yep. Great. I think with this, I'll pass again to Oscar. And
yeah, happy to. So the last trend that we'll cover here is CV on the edge, and I think many here might be familiar with that. And like the OKD device, for example. And but to give a small explanation, it's all about deploying CV or ML models on edge devices. And the Oak device is a perfect example of an edge device, something out there that can do processing and capturing of image data in real life. It can also be other things like surveillance cameras, phones, IoT devices, and anything like that. So they can process.
Anybody watching out there would like to buy their own OpenCV AI kit, they can do so at store.opencv.ai.
Perfect. Yeah, we're more than happy to shout out. It's a great thing, and here's how you can really experiment with that part as well. So it's something that has been blowing up a lot, and it's really in the time because it's really super interesting topic, right? And these devices can process the data that they ingest and then communicate somehow on that process of their data, or they can do something on their own. So some things to keep in mind though when deploying to edge devices is usually the resource constraints. You can't really scale like you can in the cloud if models are going to be run on the edge. So smaller and better hardware have really led us here. So we can have these devices to run the usually computationally heavy models and still keep these devices manageable. And the improvements here in the field is not only related to the coding part or software, but really the hardware as well. And there are ways that are worked upon from the software side as well to help with this. So keeping models small and with the fast inference time, for example, is something that is an important topic. And a way that is applied, for example, is the process of squeezing models. So they retain a similar performance, but are kept much smaller when they are deployed on these small devices with more limited capacities.
An example of that would be tiny YOLO versus YOLO, for example.
Exactly. You have something that has comparable performance, like you might lose this 0.5% or something performance, but you get something that is actually usable on these devices, also with a fast inference time. So you can do things in real time without sacrificing for a long inference every time you have to do some kind of calculation. So yeah, if we go to the next slide here, we'll see the Oak device as well. So that's a great example of an edge device. And yeah, it can really help with inference, etc. on the edge. And we did a collaboration with OpenCV on this to provide a platform for data labeling, since if you want to train any of these supervised ML models for any kind of own project, you need some labeling of the data on to either overfit to a specific use case or train a model for something specific that you might have. So these are some things about CV on the edge, but it's not only this that is important, but something that's also important for our other clients are things like privacy and security. That's right, Vahan, right?
Mm-hmm, mm-hmm. And privacy and security is becoming even a lot larger and larger topic. And as we're talking about those edge devices, an application that is heavily using some of those edge devices is becoming very, very relevant that we see in computer vision. Since computer vision is really gathering a visual data, and in Europe it's a problem, in the rest of the world it's a big problem. What this term federated learning means is that you can have really small computations and then deep learning models that will operate in those small edge devices like OpenCV Oak device. And then they can send some impulses, not really the exact raw data, to a larger federated server that will run a training on top of the impulses rather than the raw data itself. So this sounds very futuristic, but overall, as we enter more and more to this privacy game, federated learning algorithms will become a bigger place in our life, and it will really allow us better security, where we will be not really worrying about that all those cameras are gathering data about our behaviors, what we're doing, when we're doing, and so on.
There's also, similar to what we were talking about before, it really helps with the size of the data too, when you're just sending small amounts of pre-processed data to this federated server versus sending back and forth these huge, data sets and videos and images and whatnot.
Mm-hmm. Exactly. And then we had three main opportunities that we put for this webinar, but we have some kind of good to mention ones as well, and not really gonna cover too much into details, but I will start covering the SAR imagery that we see a huge application in computer vision. As you can imagine, trying to detect things from the satellites, from airplanes, will become very, very much needed. Not needed, but it's becoming very essential for so many computer vision applications. And one of the biggest challenges here is that you cannot really see through the clouds. You cannot see at night. You cannot see through bad weather and so on. So what SAR imagery does is it kind of it uses radio waves to get imagery, and then the radio waves are kind of going through the clouds, and then you're getting imagery like this on the left, and you can build a computer vision system to better understand the world from this type of imagery. And we think that this is going to be one of the biggest trends going into the aerial imagery space. So covering that a little bit for the other two, I will pass it to Oscar or Phil if you have anything to add here, please.
Yeah, go ahead, Oscar.
Yeah, so some of the other opportunities that we find super interesting as not only CV nerds, but also machine learning nerds in general, are things like semi-supervised learning, where we see a growing trend of using both labeled and unlabeled data. And like many prominent researchers are saying that this is the main way forward for machine learning to reduce the labeling effort a bit and utilize both of these settings to really achieve good performance on the huge amount of data that can be gathered. And you've seen good performance for this in many machine learning topics. So we see this just growing a lot moving forward. And another interesting technical topic is the use of transformers within computer vision. So it has really been very prominent within NLP and different language processing applications. But in the recent years, they have also been tested for using this within computer vision. And the applications has been a bit more commonplace, and models have begun to develop that are working better and better. So if this works as well as it does within NLP, it will prove to be a very interesting topic to follow in the close future, at least, to see how well applied it will be within computer vision and how widespread it might become at a later stage as well. So I think that's all of it. Just give a small conclusion of what we've talked about today. Yeah, we talked about CV ops, generally how to build a good infrastructure for your CV applications and really take into consideration the knowledge that we have from software development practices like DevOps to create a good fundamental basis to take things from trial to actually in production. Then we talked about data-centric AI, a way to keep focus on the data and not only on the model. So we don't have to spend all of these hours tuning small hyperparameters, but instead focusing on the data to provide more value for your models. And then CV on the edge, application of CV models on edge devices to capture data in real life out there and process it at the place. Something that's growing more and more. And then these three other small opportunities that we covered. And that's all from us. So we'll be happy to take some questions and talk about anything you guys want to questions or talk about.
Thanks so much, Vahan and Oscar. Go ahead and unshare your screen if you don't mind here. We'll do our trivia giveaway in a moment, but first we've got a special guest here. Hey Anna, good morning or good night wherever you are.
It's good night for me. Hi guys.
Yeah, thanks for joining us. In the absence of Satya, we've got another heavy hitter here. Joined just in time for the Q&A, so you're right on time. First, though, we're going to do our special trivia giveaway, which this week we've got a banger of a giveaway. It will be 1 year of SuperAnnotate valued at thousands of dollars. You'll be able to do all the cool stuff that we just talked about here on the webinar, thanks to our generous guests here, Vahan and Oscar. The way this works is that I will ask a trivia question that I've come up with based on their slides. You in the Zoom audience will answer that question in the chat window. The first one of you to answer it correctly will win 1 year of SuperAnnotate absolutely free. Please, if you have won in the last couple of months, do not answer and give other people a chance to answer. So, earlier in the presentation, audience, we discussed two different types of cameras. What were those two types of cameras? Oh, people were sitting on that one. Let's see, we've got, last time I gave it to somebody with a typo, I don't know. I think we're gonna have to skip it. It's gonna be looks like, Mario, did you win recently? I don't know, dude. We're gonna go with the first person to say both of them correctly here is Chintan Patel. So please send me one email to phil@opencv.org, and I will ensure that you get your free SuperAnnotate. Congratulations, by the way. We've got some great questions here. This discussion has really stirred the imaginations of the audience. So let's go ahead and start with Andrew has a question. So Oscar and Vahan, you work with machine learning data all the time. Talking about the hardware side, the camera side, what are some things that you wish current available cameras did better?
It's a really intriguing question. And you usually, from my side at least, think about it as data you have at hand or are using at play. So having other cases there, like we work with a lot of different types of cameras, like not only regular RGB cameras, but as Vahan mentioned, like SAR imagery can be RGBD, hyperspectral, multispectral, and a type of different things. And they're all good for different use cases. So I think when looking at regular like RGB cameras, these kind of things that we might see that can disrupt some projects are, of course, like blurry images, things with glares, these kind of disrupting factors that you get in the cameras to either obscure the view or do something so it's not that recognizable and coherent to the rest of the data set. So from my side, at least, I think keeping it very standardized and similar across the board would be very helpful if that would be possible.
Thoughts, Anna? What do you wish cameras did better these days?
Yeah, I mean, a couple of years ago, I heard about completely new technology for cameras, and it got me super excited. And I was thinking, so basically, the guy who was telling about this was saying, who wants current RGB cameras? They are dull, they provide not great images and stuff like that. So the new technology he promised would be completely different and would be able to provide much more information to each pixel, thus enabling more capable neural networks to work on top of that. However, these cameras are not there, and we have to stick with what we have. So I think, like for me, the way I think about this is more about, I don't think that the current cameras are doing a bad job. I think if we treat the data in a holistic way and capture like more data and diverse data when we want to train neural networks, the current cameras are actually great. What made me think about this is I had an experience, a privilege actually, of working with thermal imagery. And the way that thermal imagery cameras and sensors are built, they cannot provide the reliability yet that RGB cameras have. So each pixel that is provided by a thermal camera is kind of unique, and they have all kind of artifacts and bugs. Each sensor is completely different, and we don't have this in RGB cameras. They are all very standard. So it made me appreciate the kind of quality of the cameras that we have right now.
Yeah, I think one of the key things we see as well is the kind of many cameras are very cheap today, like incredibly cheap. And that's like a factor in how many of our clients at least can use these things like cell phone cameras, other cameras outside that are very cheap. You can really scale and apply things on a very broad scale all over the world. We usually see more specific camera systems when it comes to like production manufacturing or something else where you really are able to pay for a few set cameras that process through tons of imagery all the time. So the cost is of course also going to be a boring but important topic.
Well, the boring topics usually are the most important, I've found. Thanks for those thoughtful answers. We've also, let's see, Darshan would like to know, was asking about universities. And so everybody here, I think, is available or is involved in some way in hiring computer vision and machine learning professionals. And so I think it'd be interesting to hear from the three of you. What are some of the universities you're seeing great candidates come out of today?
It's a hard one, to be honest. So back in the days when I was doing PhD in Sweden, I quite often see a lot of German universities that have really amazing computer vision department. It's really not about the university, it's about one professor or two professors that are really leading the entire university name in a specific field, right? So we have professors that are publishing, I don't know, 15 CVPR papers, and that's kind of incredible. And even if you don't want, you're going to read one of their papers at some point, then you will kind of recognize the university by that specific person. So I wouldn't really say one university name, to be honest, but it's rather than the professors that are working in the field.
Thoughts, Anna?
I completely agree. And I wanted to add that it's not, there is not kind of a secret ingredient as like there is no university you can go to and just be successful immediately. So there is a lot of guys who don't have a higher education, university education, but they fill this gap with a lot of practice. And the biggest difference in universities for me now is how much practice is involved into the study process. And does this specific kind of education build a mental model that basically helps the person evolve and learn throughout their life, but not the education as is.
Yeah, I feel the same. Like top tier universities are, of course, like putting out a lot of great candidates, but they are also facilitating a lot of things smaller schools might not be able to do. But you can get just as a great candidate from a lot of other schools as well. So it's not about one school being that much better than the others, more like they might have resources others don't. But I think great candidates can come from everywhere. It could be self-taught bootcamp, great universities, middle universities, everything in between. So yeah, it's very much about, I think, also fit into the company, personality, other things as well that can be super important.
I've heard similar things. Go ahead, Anna.
I also can stop thinking. So the top tier universities, they select the best candidates to study in this university, right? And because of that, we cannot actually honestly compare the results, because the guys who study there, they are really great at studying something, and because of that, they got into this university. So this means these results are very, very skewed and very biased towards that. So, I mean, for me, this personal trait of curiosity is basically the best answer to, what should you do to be successful at your job.
Yeah, being curious is one of the probably core things that will get you hired somewhere for sure, is just digging around and finding stuff on your own, because I think many years ago, maybe it was possible to have a very narrow kind of purview that this is the only thing you do. But I find more and more these days that it's less about having a very solid, like a super deep knowledge about one thing, and more about being broadly aware of how things work in a given industry, in a given business, if you really want to work in it. You don't have to be a top 5 expert in really anything, so long as you understand how all of it works and you're fun to work with and work hard. The effort does matter, but you have to get lucky, of course, along the way. Got another question here about, so we saw some UI shots from SuperAnnotate earlier. Serge was asking a pretty pragmatic question, I think, which is there an equivalent of, say, Git or Mercurial for machine learning? Data, specifically.
Yeah, so we have a version in our platform that is already up and running. It works pretty well. In the upcoming year, we're putting a lot more resources there. To be honest, this is one of the main focuses for the current year, to create better versioning system, because the Git itself is a very simple thing. It's a very simple platform, but on the other hand, when you're dealing with the AI data, you need different type of practices there, and then the data sets can become very large. How to compare data sets, this is becoming another challenging problem, where with your versioning in code, when you put next to each other and comparing is becoming very simple. What about if you have, I don't know, 500 megabytes of JSON file and you want to compare them? Like, you need newer mechanisms. Yeah.
That makes a lot of sense. Thoughts, Anna or Oscar?
I mean, I don't want to kind of jump in too much in here, but there is a tool that probably you guys should check out. It is called DVC, or Data Version Control, that may already solve some of the problems, not maybe all of the problems that Vahan was talking about, but some of the problems for data versioning, DVC can help with them. But I totally agree that Git is not sufficient for data sets and for models. I think about this the following way. So there is a full and very kind of established area of DevOps in software development, and it super well covers the part where we write the code. But in data science, we also have models, which are binaries, and we also have data, which is imagery, videos, or actually anything else. And these two items, DevOps or technologies that are typically used there, it doesn't cover them actually a lot. So we definitely need new tools to work with them and kind of combine all these, different types of artifacts to work together.
Yeah, definitely. Let's see, we've got a couple more questions here. So, broadly, we talked about a little bit about automobiles. I saw, we've got Nissan and Renault, and I thought a couple other, I think Hyundai was in there, a couple of other of your clients at SuperAnnotate. Can you talk a little bit about some of the specific domain problems with cameras in cars? Because I think they're an interesting problem for a lot of reasons, but one of which, based on what we discussed here, is it's sort of a dynamic static camera, where it's the camera is more or less rigidly mounted, but the platform it's on is moving because it's a car. Yeah, Vahan, would you like to speak to that?
Yeah. So, well, we have some of those classic autonomous driving use cases. I wouldn't really go too much into details, but one of the other important applications that we see is driver behavior is becoming very, very essential and big process of understanding whether they're like sleeping or whether they're like drinking. I don't know. There can be a lot of different use cases that you don't really want the drivers to do. And then the parking is another thing. That autonomous parking is, it seems that like an easy problem, but we've seen a lot of use cases where people are doing a lot of semantic segmentation, very, very accurate semantic segmentation to help the cameras to help the cars to park. So I would kind of put those two. There's probably a lot more.
Yeah, with this kind of dynamic setting with cars traveling around all the time, you usually run into these different cases with a lot of environmental factors like, oh, it's snowing, it's raining, we have sun directly in our eyes. Like, there are a lot of these cases where you might have to run some kind of pre-processing step to actually filter out the data that is performing well enough. And I think that's why we see many cases where car companies are relying on other sensors as well. It's like LiDAR, radar, sonar, other things to cover up the deficiencies of our RGB camera. So I think that's an important part of that stage as well.
Yeah, Anna, thoughts about specifically the problems with cameras on cars?
To be honest, I don't treat, again, cameras as the biggest problem of artificially enabled, artificial intelligence enabled cars. But if we speak about cameras, yeah, I mean, interference between LiDARs is going to be a task to solve. I'm definitely sure that we will solve it, but yeah. So we probably have all seen this image of, white truck for Tesla, right? That was fatal. So it's not only about the diversity of data set, obviously, it's also the high dynamic range of the camera. So the cameras, they need to be very sensitive to kind of replicate the sensitivity of human eye, which is actually astoundingly big. So, but I'm really sure that we will solve these problems. I do see the problems in autonomous driving more lying in the area of law and people, companies not taking the responsibility, because it's really a really frightening thing to do.
It's literally life and death.
Yes, it is.
Yeah. So we're getting close to time here. First, we have a announcement about OpenCV AI game show. So many of you watched that on the premiere. Thanks for doing so. We really appreciate it. Hopefully, we'll get to do many more of those for you. But one of the open questions there was the answer to the winning contestant for our Wrong Answers Only segment. Our contestants, Vikas, Kat, and Joseph, gave their best wrong answers about an AI-generated animal. You can find that on opencv.org/game show as part of the full episode. But your votes were used to help decide which charity represented by one of those contestants will get an extra $500. Also, you voters were entered into a drawing to win one of 5 free Oak D-Lite cameras. We'll be announcing that on the OpenCV newsletter next Monday. So subscribe for that at opencv.org/subscribe to find out who won. But the winner of Wrong Answers Only was Vikas Reddy. That means that the humanitarian assistance to Ukrainians affected by Russia's aggression will get an extra $500 from our generous sponsors at Intel. Thanks so much to Intel and especially the OpenVino team for making that possible. And thanks to all of you for voting. We really appreciate it. Our guests next week will be another awesome OpenCV spatial AI contest team. It will be Jesse Brockman. I believe I saw him in the chat here. You can go ahead and say hi in the chat to everybody if you're still there, Jesse. We'll be talking to him next week about his very cool project as part of Team Midwest Defenders. With a name like that, of course, I'm going to like it. I think that's all we've got. Do we, Vahan and Oscar, if people want to follow SuperAnnotate or maybe work with y'all, where can they do that? Where should they look on the internet?
Yeah, Vahan, please go ahead.
Yeah, probably LinkedIn is the best place to follow our company, and then our website would be the best place to apply for careers. It's on the bottom. We're bringing it up next month. But
that would be superannotate.com.
Yes, exactly. Thanks, Phil.
Yeah, and if you have any more questions or anything you want to discuss with us, please reach out. Our emails are in the presentation, but Oscar or Vahan at superannotate.com. We'll be happy to talk about anything you guys might want to ask or talk more about.
Awesome. I really appreciate that. Thanks so much for joining us, Oscar. Vahan. Anna, thank you for dropping in here to be my guest co-host. I really appreciate it. We'll see you in 2 weeks on the big announcement of the winners of OpenCV Spatial AI contest on April 21st. So stay tuned for that. We will see you next week at the same bat time, same bat channel, 9 a.m. Thursday. Adios. Thanks so much for watching this episode of the webinar. Please hit that like button, subscribe, and don't forget to tap the little bell icon to be notified when new episodes drop. This week's episode was brought to you by OpenCV Courses. Learn computer vision and AI from the best at opencv.org/courses. If you'd like to be in the audience next week, subscribe to the OpenCV newsletter.